Good morning, good afternoon, and good evening, everyone. This is Clark Patterson. I'm the Senior Director of Product Marketing here at Confluent. Welcome to our online talk series. This is a continuation in our What's New in 3.2 series. Today we're going to talk about Confluent Control Center and specifically get into the conversation of monitoring and alerting Apache Kafka with Confluent Control Center. Our speaker today is going to be Nick Dearden, who is the Director of Engineering and Product for Confluent Control Center. Logistics, before I hand it over to Nick to go through our material today, we will try and capture some Q&A through the session, so by all means, if you have things as they come up, please do enter them into the question window in the chat bar of the GoToMeeting console. And time permitting at the end, we will try to take those live. If we're not able to get to them today, we will absolutely look for ways to follow up with everyone at a later date. So without further ado, I'm going to hand it over to Nick to take us through our fabulous session today. Nick?
Thanks, Clark. Good morning, everybody. All right. So as you probably all know by now, we here at Confluent are very firm believers that a streaming data platform is going to be at the heart of every modern enterprise. And today, we're going to zoom in, as Clark mentioned, on how we might monitor and operate such a platform as we scale our infrastructure. So whatever stage you're at on this journey to a fully streaming architecture, perhaps you've just started with one or two applications, or you have a focus on streaming data pipelines for real-time ETL type use cases, or you're using Kafka to maybe underpin your microservice deployments, or even you're collecting continuous streams of data from your sensor and device at remote locations, you're very quickly going to realize that this platform has become a central and critical piece of your system's infrastructure. Of course, as such, you need to actively be monitoring and managing that to ensure everything is operating smoothly. So at Confluent, we think we want to approach this from a very holistic perspective. And there are really two sides of the coin when it comes to monitoring a Confluent streaming platform. When you first attack this problem, probably the questions that come to mind are of the traditional kind of operator-focused type. Are my systems up? Are they working? Is something maxed out? Is something exceeding a tolerance? Are my CPUs too busy? And so on and so forth. There are, however, another side, another set of questions that we might want to address here, which come more from looking at it from the perspective of the applications that are working against my streaming platform. So are all my messages being delivered? Did they arrive on time? Did they all arrive on time and in order? And what we normally see is that probably depending on your background or your role, you start approaching this monitoring question from one side or the other, and eventually you come to build up this composite picture in your mind of what it is that you're looking at to make sure both that the infrastructure itself is behaving and that it's providing the service you expect it to provide to all the applications that you have running against this platform. So if, for example, you have an unusual spike in some system metric, then you want to track that through and then establish what the corresponding application impact might be. Likewise, if your application monitoring is highlighting some issue in message delivery, then you want to go and look at the broker and systems kind of side of the world to discover what happened leading up to that problem event, what happened that was correlated with it, and then figure out how to prevent a reoccurrence of that. So let's dive into, if you like, the hedge side of the coin a little bit and talk about monitoring and metrics against a set of Kafka brokers. But before we do a little detour here, this is actually one of my favorite little sayings from the world of statistics that's super relevant here. So, before we get too far down this particular rabbit hole, it's important to realize that a Kafka broker exposes something like 165 different metrics over JMX, for example, and all of those metrics are interrelated by this kind of invisible web of dependencies and correlations. Some are leading and lagging and indicators of each other and so on. So oftentimes looking at all of that data can make you feel like you need a PhD in Kafka administration to be able to make sense of it all. So what this saying here simply means is, if I see metric 1 changing in lockstep with metric 2, that doesn't actually mean that one of those two effects is causing the other at all. There are a bunch of famous examples of why that's the case. This one tracks the divorce rate versus the amount of margarine being consumed. And if you were to blindly look at this, you could say, I guess you could hypothesize that one of these things causes the other. And probably neither way around is terribly likely in this example. Okay, so how that translates into monitoring of a streaming infrastructure is, you have these 160 different metrics. You can add and collect more of your own on a host level, for example. And you could graph them all using one of the common sort of time series charting solutions. Maybe you like Grafana or Graphite or one of those type of things. But without understanding these interrelationships between all the numbers you're looking at, it's very hard to make sense of what that actually means in terms of the operational quality of my infrastructure. Of course, at Confluent, we think we have some of that knowledge. In fact, what we wanted to provide when we set out to design this product was our own opinionated take on how to best monitor a cluster for signs of problems, leading indicators of trouble, and so on. So, at Confluent, we have a lot of experience working with the world's largest Kafka installations. And drawing on that depth of experience, the Confluent Control Center can distill down the data from all these different 100 and some metrics into a handful, if you like, a manageable set of KPIs and supporting details that support both a broker and a topic-centric view of your system's health. Don't worry about squinting at the screenshots on the right. We'll make time for a demo in a few minutes. You'll be able to see that stuff in a little bit more detail. The other side of the coin now, moving ahead, if you like, we will look at what we call application or end-to-end stream monitoring. So the notion here is pretty simple. Typically, you're producing all these messages into your streaming platform for a reason, which of course is that you want some other set of applications to be consuming them. So imagine, for example, that you have application A and application B producing into a couple of topics, and you have applications C, D, and E are all consuming from those. What you want to be able to assure yourself is that all the messages you produced on the one side were consumed on the other side by the other set of apps within whatever your target latency SLA actually is. So what the control center can do for you is track not only that all those messages are being consumed in all the places you expect them to be consumed, but also how long it took for them to get there, whether there was any data corruption in transit, and so on. All right, so that's the intro part done. Now we get to do the fun piece. Let's just switch over here. All right, so this is the initial view of Control Center when we open it. This is what we call the broker-centric view of our system's health that we talked about. Let's just zoom into a slightly more recent time frame so we can see a little bit more detail here easily, in case this screen's getting a little bit compressed for you in the recorded video. So this is roughly broken into three main areas. There's a rectangular portion in the top left here. This is what we would call the KPI section that indicates my overall cluster health. These are the derived metrics, if you like, headline indicators. These are the ones we would recommend setting your initial alerts against. To see in here, you can get lots of leading indicators of problems. So, for example, if you're at all experienced with Kafka, you'll know that there should always be exactly one machine acting in the role of controller at any given time. If you have 0 or more controllers, then that's definitely a problem, and you want to know why that's happening. In fact, if I were to click in here, I can see there's a little time series view, so that I can see perhaps controllers have been up and down and on and off of the cluster system over the last time period that I'm drilling into here. So you can see if the controllers are flapping, for example. Likewise, if my network pool usage has been trending super high, in this case it's really low, this cluster is very quiet, that's going to indicate some kind of problem. To the right of that, we have this graphical chart area here, divided into two sections. The left side is measuring the volume of data that's being produced into my broker cluster. On the right-hand side, we're seeing what's being fetched back out of these clusters. And so the area chart here is the actual data volumes. The histogram beneath is a request count. Okay. We hover over there, we'll see that actually. And we're measuring the latencies of different grains down below here. And the bottom section of the screen, real quick, is a tabular view of data about each of these brokers. And what you'll notice as I hover across this table, and actually when I was on the chart before, is that all three of these views are linked together. Right? So here I'm highlighting the contribution of broker 0, for example, in the top charts to the data that's being fetched and consumed, highlighting its latency metrics and so on. Same thing with the other two guys. Likewise, if I came over here, highlight one of these guys, can even drill in and see what's happening right in the actual request queue for these things. And if we just scroll across here, we can see we can also, for example, check which of these brokers is storing the most data on the disk. If, like me, you're not an accountant by training, you find it kind of hard to read a large grid of numbers, especially as you add more machines in this cluster, it's pretty easy to compare the relative magnitudes with this kind of a view, or even to investigate the trending view of each of those data points there. Let's just switch over really quickly to what I would call the topic-centric view, right, of my cluster health. So it's very similar in its construction to what we just saw on the broker-centric view, but here the line items themselves are actual topics. So slightly different set of KPIs here. Of course, the fetching and consumption is the same, but here the line items in this table are all individual topics, and we can see their relative traffics in these couple of columns here. Check the partition and replication status and so on. Right, so these are all pretty even and pretty healthy right now. If I find one that is, let's find one that's a little busier. Right, so it'll be this one here. Maybe I want to drill in and look at the details of an individual topic. Here what we can see is that I have rows representing the individual partitions of that topic. Right now I don't have any monitored consumer groups against those partitions, but if I did, I could drill from here to look at the actual data flow. And what I'm seeing on the right here is the placement of these partitions and their replicas across my brokers. So in this case, I only have a 3-broker cluster and I have 3 replicas, so of course they're all full. But these guys here would be color-coded, indicating any issues in the event that there were any. Oftentimes what you'll see is that there's a strong correlation between which of your replicas is having a problem and the broker on which it resides. So if you have a broker with a file system issue, perhaps a little bit of disk corruption or something, and that disk is going slow, you'll see that all of the replicas of a given broker are starting to struggle a little bit, and that'll help you pinpoint what that root cause problem is. So remember we talked a few moments ago about the two sides of the coin. So we've looked at the first side, the broker and topic monitoring. Let's go look at what we call the application or the end-to-end stream monitoring side. And so what we're doing here is looking at the headline level across all of our monitored streams in the cluster. And we're comparing the, in this top chart here, which you'll see updating itself as it scrolls by, there's a line, which I hope you can see at the top of the area, which represents the number of messages that have been, that we expect to be consumed across all our topics. And that area will fill itself in as they are actually consumed. So in this example, let's just go click here. So these are my 2 topics. I only have 2 topics taking traffic right now that I'm actually monitoring in this system. And on this side, I can see what the consumer groups of those 2 topics are. Right? So note that I have a asymmetry between the number of topics that I'm writing into and the number of applications that I have consuming from them. And so that leads me to what we call this expected consumption, which is, as you see, is the label up here. So there's a subtlety to this which is quite important to understand, which is that we're not comparing consumption with production, because for every message, one message that I produced, perhaps I expect to consume it in 3 different applications. So the expected consumption of that one message is 3 times. And that's what's actually getting tracked here. That's the only way we can assure you that every application that you're tracking is doing what it's supposed to do and doing it in a timely manner. And as we go further down the chart here, I can drill into details of individual applications or even of individual topics and partitions, right? So if anything shows up, what will happen is that this top chart will have an orange area highlighting where we think there's some delay in the message consumption. I could drill all the way down to say that it was application X reading partition Y of this topic that is having the latency spike, which is super valuable for me to be able to do that. Let's just, we should mention as we pass by here, I guess, that it's possible to wire up a single instance of the control center to many different Kafka broker clusters in order to monitor them. So if perhaps you have applications deployed in multiple data centers, or you have applications that require their own cluster for various compliance reasons perhaps, or because that's the way you want to try and guarantee various SLAs, you can still aggregate all of their performance data into the cluster against which the control center is running. So the way the control center is working underneath is it actually leverages Kafka itself to collect a lot of this data. So we're producing all those metrics about the brokers and the topics and things into special topics that get created when you first start the control center. And the control center itself is a streaming data application that reads all those streams in real time and correlates them. And that's how it's tracking the difference between, for example, the messages that are getting produced and the ones that are getting consumed. In this example, I only have one cluster wired up here. And naturally, it's fairly boring to sit and watch this screen the whole time to identify any leading indicators of trouble in your system. So it's entirely possible to set up what we call alerts to fire off in the event of any metrics going out of bounds from what you expect. So if I were to fill this in here, and we'll just take a quick look through the things that it's possible to monitor. So if I were to monitor a consumer group, that's an application that's reading whose latency I'm trying to track, that we just looked at in the stream monitoring side. This is where I would choose to do that. So for a consumer group, right, these are the three applications I had that were reading the data in my topics. I can be measuring the maximum or the average latency over some time period, and the consumption difference. Consumption difference is basically the thing that says, did I miss any messages? And depending which one I choose, I can measure it to be, out of some bound, as evaluated over some time period. That's what this buffer is here. So if I decide that I am okay with a little blip, perhaps due to some transient network issue or something that maybe only lasts 15 seconds, I would apply a buffer of maybe 20 seconds here. In that case, the alarm would not trigger. So that avoids me being inundated with kind of noisy, spurious alerts for which I'm not that interested. Likewise, if we go look through the broker level, right? So if I were to monitor my broker cluster, these are essentially most of the metrics that you saw on the first page, right? And again, they can all be monitored in exactly the same way, some threshold, evaluated over some time period. And for any broker which violates the constraints specified in this alert, the trigger will fire. It will tell you which broker caused the value to be exceeded, and you'll actually be sent a link that takes you directly to the chart that highlights that data in the time period when the problem occurred. Oops. And finally, the topic-centric view of the world, right? So on cluster X, I send an expression here, so I can have this be evaluated against a set of topics. If it were all my add click underscore asterisk topics, for example, that's a nice, easy way to set the same set of triggering conditions to be evaluated against more than one topic at a time. As new topics are added to the system, they will automatically be evaluated against the constraints that you want to enter here. And then for each of those topics, again, I can monitor its health against, well, whatever metric I want. I just flip back to the beginning here, right, just close the loop on this, right, you see that the alertable things were all of these, what we call these KPIs here, and I think we covered off all of these guys in the table too, right? So that enables us pretty simply to not only come in and take a glance at the health of our system, and also to be proactively alerted, right, when something is trending out of bounds for the application administrators or application owners amongst you. That means I'm interested in saying, did my application get all its messages? Or did it have some delay in producing and or consuming them? I can be alerted when that is no longer the case. And we can come in here and see what correlates at that same time across this view of the system and this view of what my applications are seeing of the system. Likewise, if I'm wearing my systems operator hat, for example, a lot of folks will run a set of Kafka clusters which are effectively an internal service for other application groups to make use of. If you're one of the folks running that and you need to make sure it's all up and available for your users, then this is probably the set of views here where you're going to set your alerts on, and these will give you leading indicators, right, of problems that may occur. So for example, because Kafka is a fairly complex distributed system, it's unusual for it to be essentially offline in its entirety. What's normally going to happen in the event of some issues is you'll see retarded service in some aspect, and usually that will show up as either a throughput problem, a latency problem, or the unavailability for production of one or more topics that are on an affected broker. And so it's a kind of simple up or down measurement doesn't really cut the mustard for this. And that's why we think it's important to be monitoring these things and say, hey, one or more of my brokers is, as it were, slowing down, or something is trending towards unavailability. And that's why we think it's super important that you know that ahead of time. So this is a nice complement to anything you might be doing that, for example, tracks logged errors and warnings. Maybe you have a Splunk or ELK kind of setup where you're consuming those logs. What we're hoping to do here is allow you to see before the log message from your applications is actually generated that something is a problem. And in fact, I promise I didn't make that up ahead of time, but I've just lost my active controller in this cluster. So this is an AWS cluster that I'm running, and looks like we have some latency amongst controller election. And so the controller has just gone offline. You'll see that here. And now the broker cluster itself is highlighted in orange to indicate to me that there's a problem that I need to go investigate. That's quite an amusing coincidence. Promise I didn't set that up. I'm not going to troubleshoot it live, but it's a great illustration of what will happen when something does in fact go awry. Likewise, on the topic side, leading indicators of topic unavailability, as well as latency from the broker side, might be an unusual spike upwards or downwards in throughput of traffic against that topic. If maybe a rogue application is started or an application into which a new bug has accidentally been inserted, right? You could see a big spike of maybe it's accidentally rereading all of history from that topic when you expect it only to be tailing the last few minutes. You see a giant spike, and that's going to drag down the performance and the throughput, but potentially for other applications that are trying to read and write that same topic. So I think that's good for a whirlwind tour here. How are we doing on questions, Tracy?
Yeah, we got a couple here, Nick. The first one is someone's asking a little bit if you could chat a bit about the performance impact of running Control Center on the cluster itself.
Oh, excellent question. So you've got a couple of different ways that you can choose to deploy this, and then so I'll talk about that first, and then I'll talk about the potential performance impacts that you might see. So if you have a very large environment, perhaps you're trying to monitor that scenario we talked about where you have broker clusters in many different data centers or for different LOB purposes, line of business purposes, then what we might recommend is that you run the control center only on one central cluster. And if you have a giant deployment, if you're like a LinkedIn kind of scale company, you probably have a dedicated little cluster just to run this on. And when I say a dedicated small cluster, I mean, 3 small brokers, maybe 3 zookeepers co-located with them on pretty small VMs somewhere. And the reason for that would be that you want to ensure that your monitoring cluster is insulated from any difficulty that any of those other systems may be having, right? So you want to avoid getting into that kind of catch-22 situation of using a Kafka cluster to monitor a Kafka cluster, and that cluster has some problems, so now I can't monitor it properly. So that's the, if I'm at really big scale, that's the best practice. If, however, for the other 95% of us, it's perfectly normal and acceptable to run this against the same cluster that you're using for normal operations. If I was to try and quantify the impact, I would say it is producing all these different topics, right? So let's talk about the data volume that goes in there. So to power the broker and topic-centric views of the world that we're looking at here, the brokers themselves are issuing messages onto a dedicated metrics topic, one message every 15 seconds, or is it 10 seconds by default, right? So that's not very many. In this example, I have 3 brokers, maybe I'm producing 4 messages per minute per broker, that's 12 messages. So that's a very small traffic impact. You can easily multiply that up by the size of your environment. Those messages are relatively large, perhaps 500-600 kilobytes each. And then the control center itself, being a streams application, using the Kafka Streams APIs, reads and writes some intermediate topics in which it stores the aggregates. That's how, for example, we can come up here and select a custom date range, and maybe we can look at this day last month, or a particular range in history that we're interested in. Those topics themselves, again, take relatively little traffic. They're only taking a couple messages a minute. We can probably even go and see how much space they're consuming in my test cluster here. Because that's, you'll see all these topics in my list whose name starts with _ Confluent Control Center. These are the actual internal topics which are making this work. So you can see here that the actual traffic is vanishingly small on those top few. Let's just sort this so we can see the largest ones at the top here and see just what the impact is. Right, so I'm taking 20 kilobytes a second. Right, so that's, again, vanishingly small in terms of impact. If I look at the...
Thanks, Nick. Nope, sorry, Nick.
I could talk about that a bit more. There's another side to it that we should clear up for folks. If I look at this streams monitoring side of things, so the first thing to say here is that you can use stream monitoring without the systems monitoring and vice versa, right? So if I'm using this one, then my first decision is which of my streams and applications do I actually want to monitor? Because this is not an all or nothing switch, right? I can choose to say only these topics and these consumer group applications are the ones that I want to be tracking their performance of. Some others, maybe I don't care so much, or they're for development purposes or something less mission critical and so on. And the way that's actually working is that we add what we call an interceptor, a monitoring interceptor jar, which is a file that you drop into the class path of that consuming application or your producing application. And what it's doing is it's tracking the actual communications between that application and the Kafka cluster. What it's doing is it's accumulating internally like checksums and counts and hashes, and every 15 seconds that application is going to send one message to a special monitoring topic saying, in this 15-second window, I, as producer or consumer X, have seen 28,004 messages go by with this aggregate checksum and hash and so on. And it's those streams of monitoring messages which are then compared to establish that messages are being delivered correctly and on time. So again, you can do the math there to work out how much traffic that's going to generate for you. So these messages are much smaller, just a few kilobytes each. You're going to issue one every 15 seconds per monitored application per topic partition that you're monitoring. So if you multiply those 3 numbers together, you'll probably arrive at, for a reasonable installation, maybe a few hundred messages a second. So again, it's really very small in terms of traffic. The heaviest portion of running the control center is the actual control center application itself, where it's doing all the logic of consuming and comparing these streams. And that's probably something where we'd recommend you want to dedicate 4 CPUs, maybe 16 gigabytes of RAM on that box. Should be plenty to monitor even several dozen brokers and hundreds of topics. Sorry, Clark, you had another question there?
Yeah, I mean, we're up on time, but I think this is an interesting one if you could hit it fairly quickly. But regarding stream monitoring, can you talk a little bit about how that works? Specifically, is it working by counting offsets?
No, it's not. So as I was just alluding to, it's working by actually checking the messages themselves. So offsets, I think, is if you were to go and search on the interwebs, you would find that offset tracking is the sort of de facto, historically recommended best practice for establishing whether your consumers are behind, where behind is a sort of number that's open to interpretation for you. You can say, a broker can tell you that the current high watermark on a given topic is message 1 million, for example, and that a consumer group can tell you that it is currently consuming message 800,000. So you can extrapolate that, oh, I'm 200,000 messages behind. But it doesn't give you, for example, any rates. So you don't know how long it would take you to consume those extra 200,000 messages. Maybe you have a cluster of 40 apps, reading them, and you'll have consumed them all in the next 2 seconds, and that's okay. You can't establish that simply from offset counting. Neither is offset counting going to tell you whether there's any message corruption, or indeed whether all the messages are actually making it through to their destination, or if the consumer has skipped some for some reason, maybe you have a glitch in the code there, or some transient network issue or something. So that's why we feel that this methodology of having these monitoring interceptors that are co-located with your producing and consuming applications is the strongest way to assure yourself of the necessary performance and availability. Good question, though.
Excellent. Thanks, Nick. We do have a couple other questions. One of them I'll hit real quickly, which is where can folks learn more? If you go to confluent.io, there's a specific page on Confluent Control Center on the product section. So by all means, you can find more information there. The other ones we'll look to do some sort of follow-up, perhaps a blog or something that or that can address those things in more detail. All this stuff, by the way, totally available from us from our website. So if you go to our download section, you can get a 30-day trial, which includes Control Center and all the great things that Nick showed us today. So by all means, do that. We'd like to encourage you to continue to join us on our series here. Nick, if you can just flash forward real quick. For the next topic, will be all about data pipelines made simple with Apache Kafka. We added some great new capabilities for single message transforms into Apache Kafka specifically. So we'll get into all the great details in terms of how that stuff works. That's next Thursday, March 23rd, so we hope to see you there. And last but not least, we would love to see you at one of our upcoming Kafka Summit shows. There's one next month, May 8th in New York, another one in August 28th in San Francisco. There's a discount code for anybody that is able to come out there, but we will talk about all these things that you hear in this online talk series and more from the experts that are actively creating and curating this great customer talks and everything else. So I hope to see you at one of these upcoming sessions. So with that, I would like to thank you all for your time today. We really appreciate you taking the time out of your busy schedules to join us, and we look forward to seeing you on an upcoming Confluent online talk series. Thanks, everyone.